An economics professor wishes to estimate the mean value of earnings per share of the list of the top 1,000 companies in Canada during 2004, as published by Globe Interactive. He selected a random sample of 30 of the companies and recorded their earnings per share. The sample data are given below. You can see the table. So the first company, decimal 30 per share, 139 for second company, and so on. The population is known to be approximately normally distributed. Suppose that population standard deviation is 3.04 earnings per share. We have to obtain a point estimate of the mean value of earnings per share of the 1,000 companies and to find a 95% confidence interval estimate of the mean value of earnings per share of the 1,000 companies. So we have 30 companies and we are looking to calculate the mean for these 30 companies. So we can calculate the mean for this sample size of 30 as the sum of all these earning shares, decimal 30 plus 1.39 plus decimal 51 plus and so on. We put together all of them. The very last one is negative 52 divided by 30. If we plug in our calculator, we have the mean for this sample of 30 companies, decimal 298 earnings per share. So this will be the point estimate of the mean value of earnings per share. Now we need to calculate the 95% confidence interval of the mean value. So we know that when we calculate the confidence interval for the true mean for the entire population of 1,000 company will be this point estimate for our sample minus error and the mean of our sample plus the error, where the error is critical value for the desired confidence level times the standard deviation of the entire population divided by square root n. Now, to calculate the critical value, we have to take in account that confidence interval, 95%. So 2.5% we expect to be more than the upper limit of our confidence interval, and 2.5% will be less. So we are looking to calculate the cutoff point, the critical value, at 2.5. So this will be decimal 0.25. Once more, the area that we can read from the table is between z equal to 0 to this critical point. And this area will be decimal 475 because half of our graph is decimal 5. So decimal 475. If we are looking at the table, inside of the table we are checking for decimal 4575. This corresponds to a z value 1.9 and 6. So critical value for us at alpha over 2 is 1.96. times 3.04 divided by square root 30. Once more, we have a sample size of 30. If we calculate this, we have 1.08785, so let's round to 3 decimal places, 1.008. So when we plug in our formula, so we have the mean for our sample plus and minus error. So when we build this %95 confidence interval, we have that the mean we expect to be between, so 0.298 minus 1.088, so we have negative 0.79, and 0.298 plus the error, so plus 1.088, we have 1.386. So we have 95% confidence that the interval minus 0.79 and 1.386 will contain the value, the true value of the mean value of the earnings per share for the entire population of 1,000 companies.